Yeah, so first of all, thanks for coming. Really appreciate you taking the time. To get us sort of in the mood for this, I want you to think about for a minute the last time you were super excited about something. The last time you were like, this was like a magical experience. Like maybe you were hiking or you were doing something with your kids, something really exciting, and don't say it. Let me guess. It was something about compiling, compilation, TypeScript compilers. That's what I thought. So that's what I'm here to talk about is the AOT compiler for Angular. Um, how many of you are using Angular to some capacity? Yeah, so that's good. And how many of you are using like the Angular CLI or any of you using Webpack for like manual? Yeah. Uh, and have any of you run into problems when you try to compile Angular for production where something doesn't work right or it throws some errors? Sort of a notorious problem in the Angular community. So I wanted to try to dig a little bit deeper into the AOT compiler and figure out what's going on, why is this doing this, and that's what we're going to talk about tonight. So first, my name's Sam Julien. I'm a C# and JavaScript developer and consultant. I created a comprehensive video course called Upgrading AngularJS. It's the best NG upgrade resource on the planet, humbly speaking. I'm also the co-organizer of Angular Portland, which Alex comes to a lot. And that's actually happening tomorrow night. So if you really want to like double down on tech meetups for the week, you can come to the complete other side of Portland to the Pearl and come to Vicasa tomorrow night. And we're going to have a really cool couple of talks there. So compilers can often seem like magic. and but why even bother trying to figure out how they work? Well, learning about a compiler can help us figure out best practices in our application, which eventually helps us avoid bugs and save us time and money, which is basically the point at the end of the day. Because a lot of the time I'm working on something in my Angular application that seems to be working in development mode when I have Webpack Dev Server running or ng-serve through the CLI, and then I run that AOT flag or that production flag, and all of a sudden this happens where everything just sort of crashes and burns. So the goal is to try to figure out what is happening behind the scenes and a couple of common pitfalls that happen with the AOT compiler, and then the benefits that we get through some fancy tools and things like that when we dig down and understand what's happening with the TypeScript compilation. So before we do that, let's take a step back and learn a little bit about Angular and how it compiles its code. So there's actually two different modes that Angular has for compiling. There's a just-in-time or JIT mode, which is also known as dynamic translation, and that happens in the browser. Angular ships the compiler code to the browser, and everything gets compiled there and then served up. On the other hand, we have the ahead-of-time or AOT compilation mode, which is also called static compilation. And this is where ahead of time we're outputting V8 optimized code and then serving that through the browser. What we end up seeing is that the JIT compilation appears to be much more forgiving, and that's what we want to figure out. Sometimes we're working on things and things are going fine and then it doesn't work in AOT. So what's the point of learning or why would we even attempt to use the AOT compiler if we could just use just-in-time all the time? This may seem like an obvious answer, but I kind of hinted at it. When you're shipping the code to the browser, you're going to have a much bigger bundle size because you're having to ship that compiler code in with your bundle. So along with your other dependencies like any sort of date picker or jQuery or anything else that you're shipping, you have to ship this compiler code, which actually is a pretty big part of Angular. It's almost half the size of Angular is just the compiler. So a smaller bundle size, that's one obvious answer as to why we would use ahead of time compiling. We also get a lot faster rendering because instead of having to compile that code on the fly and then render it, we've already got pre-compiled code that we're just rendering in the browser. Third, we have fewer asynchronous requests when we use AOT compilation because we're not having to go fetch our HTML templates and CSS style sheets. The AOT compiler inlines all of that stuff into our JavaScript, so we don't have to go get separate requests for all of our templates and style sheets. Fourth, we can detect template errors a lot earlier. Now, this is sort of a blessing and a curse. That's one of the ways that the AOT compiler often will catch things that the development server didn't, because the development server is sort of running on the fly, and as long as it's running correctly, then it doesn't complain. Whereas the AOT compiler is going to catch your template errors before they ever make it onto the browser. So that's great. It just sometimes means we've got to add an extra step into our process. And then lastly, AOT offers some better security. Since it's compiling our HTML templates, that gives us fewer opportunities for things like injection attacks. So that's why we're putting the time and effort into AOT. Yeah?
So is there a reason why you would not use, you would do the flip of that?
Only in development. There's really not a good reason to try to use the just-in-time compilation in an actual environment. Yeah.
I think it's increased time for compilation if you in development.
Right, yeah.
Significantly.
Yeah, definitely, for sure. And so this is just a little visual representation. This is a visualization through the Webpack Bundle Analyzer, and on the left, you can see the Angular code with the compiler left in it. And then on the right is the total vendor build, and you can see how without the compiler, Angular is a lot smaller. Now there's still a little bit left of Angular down that's not in the red, but you can see just how much of the Angular package is taken up by the compiler. So at a high level, we can think about compilers all kind of doing a similar process where it analyzes the source code and then parses it into something and then generates resulting code. Now, before you jump on me, I know that it's more complicated than that. We're not going to talk about lexical analysis and semantic analysis and optimization. We're not going to get into that right now. However, I do in the slides have some extra resources, a couple of screencasts and articles, and a book that I really like called The Imposter's Handbook that has a whole chapter on compilation. So we can get into that. But really, the AOT compiler is sort of a spin-off of the TypeScript compiler and does a similar process. With the AOT compiler, we parse through our templates, so our decorators, templates, and style sheets, and those get parsed into a TypeScript abstract syntax tree in the form of some metadata, and then that generates TypeScript and JavaScript from there. And there are some advantages to doing this with parsing the HTML. You get things like better debugging. I don't know if you've ever noticed in an Angular error, it can catch template errors that then give you the line number of where that template error is happening, which you couldn't do in Angular 1 because it wasn't compiling in the same way. We also have the opportunity for server-side rendering because of this. We can replicate this same compilation process in C# or Java and get that same compilation down the line. And then lastly, we get a lot of really nice tooling through this process, and we're going to have more on that later because that's sort of the payoff of this complex process. If you're, how many of you are somewhat familiar with abstract syntax trees? Or, yeah, of course James is. There's a really cool resource called AST Explorer. Let me see if I can pull it up really quick. Well, it's mirrored, but
only way to do it.
There's actually a TypeScript option here. Let me mirror the screen really quick so I can show you something. Yeah, so what's cool is if I add a decorator to this, like in Angular we have a component decorator, you can see over on the right here, it tells us that it's a decorator, and it builds out this whole tree. So this is an example of an abstract syntax tree. And in fact, the AOT compiler does generate, it's a JSON, it's called metadata.json. And you can see an example of, so this is a really cool website, it's called AST Explorer, and I have a link to that in the slides for you. Let's go back to get my setup here. Sort of a whole process here. Okay, so now we can look at there are three phases that the types or the AOT compiler goes through, and they don't quite match up to the classic parse or analyze, parse, generate, but it's something like that. And this is following along with the AOT compiler official documentation, which I've also got a link to in the slides. But the first phase is the code analysis or parsing phase, where the TypeScript compiler actually does some of this analytic work in the first phase. It goes through and emits some type definition files for the AOT compiler in order for it to generate that application code. And then there's an AOT collector that goes through and analyzes the metadata in the decorators, those annotations. And then that outputs metadata information that pairs up with the generated type files. So there's a sort of one-to-one correspondence between the .d.ts and the .metadata.json files. And those metadata JSON files are the ones that have the AST, sort of the representation of the structure of the application. Now, this is the first opportunity for pitfalls when you're writing this code, because the collector actually only understands a subset of JavaScript. And so this is one reason why things can work in development but not in production. So for example, the AOT collector doesn't like private template variables, it won't accept default exports, and there's a whole number of these. And I've got a link in here. There's a company called Wrangle that's a consultancy in Toronto, has been keeping a running list of all these do's and don'ts with your AOT code. So that's a really helpful resource. And so that's just one thing to keep in mind, that you have to use sort of a pared down set of JavaScript. It's nothing too crazy that, it's nothing that is like so out of this world, but it's just things that you need to know. For a while, you couldn't actually use arrow functions in like provider decorating and things like that. Luckily, in version 5 of the compiler, they've kind of added a trick where they go through and automatically change those arrow functions into exports so that you can still use those arrow functions. So then phase 2 is the code generation for the AOT compiler. And the first thing to know here is that the collector doesn't try to actually understand the metadata at all. All it's doing is like a little robot that goes through and organizes the whole syntax tree. It makes notes about errors when it comes across them from a syntax standpoint, but it doesn't know anything after that. So then it's the compiler's job, the AOT compiler's job, to actually interpret that metadata in the code generation phase. So this is the second pitfall, because the AOT compiler still understands all the syntax forms that the collector does, but now you have the danger of semantic violations in addition to syntactical violations. And these surface in the form of metadata errors. So for example, the compiler can only reference exported symbols. You can't make inputs private or internal, and then data-bound properties also have to be public. So there's a whole list of these. Luckily, in the most recent version of the documentation, the Angular team has put together a whole list of these metadata errors and what they mean and how to fix them. So I've got a link in the slides for those as well. So that's phase 2. And then lastly, we have phase 3, which is the binding expression validation phase. So that's a long way of saying it's a validation phase, where the template compiler uses the TypeScript compiler to then validate all those binding expressions in the template. So that's where we use the double curly braces to bind between our component and our template. So the template validation is what produces error messages when type errors are detected in the binding expressions, kind of like how type errors get reported by the TypeScript compiler against a .ts file. So it's sort of another layer of protection there. So those are the 3 phases. We've got code analysis, code generation, and binding expression validation. Now, I'm sure you're sitting there thinking, like, this is ridiculous. Like, why am I sitting here listening to a talk about compilation? So there's actually really cool things that can be done by knowing these. So now we're going to look at some fun tools. So I'm going to duplicate the screen again. And get to my notes here. It has vanished on me.
Center cap.
No, it's I think when I duplicated the screen, it like hid away from me. Let me see something. Move this back over. There we go. Now I can. Okay, so there are a few different things you can do with this. You can analyze the source code, you can automate changes to it, and you can visualize it. So let's look at analyzing it. So this is a tool. I'm just basically going to show you a handful of open source tools. Not going to do a whole lot of live coding here, but just show you some open source tools that are both specific to Angular and also just TypeScript tools. So this one's called Codelizer, and it's a Angular linter by Minko Geshev, and it provides static analysis for Angular projects. And I've got links to all these, so don't sweat trying to take notes or anything. But essentially what this can do, you can set up different rules. Let me scroll down. There's actually a demo GIF here. But you can set up custom Angular linting rules according to, it's built in already with all the style guide things. So in this GIF, you can see that at first they don't have component in the name of the class. They're not using the name input correctly, and they're not implementing the on-init interface correctly. And Codelizer goes through and is doing static analysis on the code and uses IntelliSense in Visual Studio Code to hint at what needs to happen. So that's a pretty awesome tool. And there's actually now quite a few contributors to this, and it's a highly customizable tool. And you can use it both with the CLI and in a custom project like the Angular Seed project.
And that's a plugin to Visual Studio Code?
It's a linter, so it's an NPM package. It's a node module that you would just install.
So you could use that in Visual Studio?
It's built into the the CLI, but then it's also you can clone it and use npm and install it as your own linter using a TS lint. Yeah, it's actually built into CLI now. You can specify what to use it as the linter, and then just do ng lint. And it does it for you. So pretty cool. Another great tool that actually isn't specific to Angular, but it was made by an Angular wizard named Yuri Shaked, is a tool called TypeWiz. And TypeWiz uses the abstract syntax tree to go through and figure out what the missing types in your TypeScript code are. So in his example here, we've got a function where we're adding A and B and returning A plus B, and you can run TypeWiz, which is either a Webpack plugin or a node module, and it'll go through and it'll just infer the types for what you're doing. So this is really helpful when you're doing things like upgrading from AngularJS to Angular and you're moving a bunch of JavaScript code to TypeScript. You can use this little tool to help alleviate the pain of going through and trying to add typings to your project. So again, not specific to Angular, but really cool for TypeScript use. And then Minko, who made the Codelizer tool, is really nonstop. And just this guy is my coding hero. He made a couple of other just incredible tools. So the first one is called ngRev. And this one I can actually do a live little demo for you. This is a tool that uses the AOT abstract syntax tree metadata. And you basically can point to a TypeScript config in an Angular project, and it thinks for a second, and then it builds out a visual representation of your application. So it shows me all my dependencies here, and then this is just the sample project from my upgrade course, and I can double click on the app module, and it shows me all the different components. It's got a legend over here, so this is the metadata that's happening, and then these are the components, and then these are the services or providers down here. And I could drill into the customers component and see that I've got a template and I've got dependencies here. So there's a pretty slick payoff to being able to use this. You can even drill into the template. Since the AOT compiler is a template, it starts with the template. It goes all the way down from the templates into the TypeScript code.
This is using the AOT compiled code? Or?
No, this is actually just using the TypeScript config. This isn't even, basically, he uses the AOT compiler, but you basically just pass it the TypeScript config, and then it runs it through using the same process to build that abstract syntax tree. And that's based on yet another project that he did called ngAST. There's a link to that in the GitHub for ngRev. Let's see, I can open that for you. You can read more about it. It provides that. So let's see where. Oh, he doesn't have a link to it here, I guess.
So it's the same guy who made the original, right?
Yeah, it's the same guy who made
Codelizer.
Codelizer, and it's this uses, I could just type it in, ngAST, which is a tool he made to basically make an API for the AOT compiler. And then there's one last thing that he did. Oh, did you have a question? Yeah.
Can you go back to your display?
This guy?
Yeah. So the customers table is also an Angular component?
Yeah, it's a nested component. So then if I go in there,
You can now,
you can see the template component in the template. And then I thought there was a way to open up the actual code, but I guess not. So yeah, pretty nifty tool. And then the last, also from Minko, he basically used that same thing. And I was going to try to show this as a live demo, but I think that he hasn't updated this since version 5 came out. So I'll just show you here. He made another tool called ngWorld using the same abstract syntax tree, but basically he visualized the code base, the abstract syntax tree. This is the Christmas edition. He also has an edition that's not, but here's the about module for his application. There's a grid component, and you can just go through and actually step through. In the update, I was really bummed that I couldn't get this working live, because in the updated version, you can actually click on the trees and you can like change the code at the same time. But I couldn't get that working on mine. But I've linked to his talk. He gave a talk at a conference where he demoed the most recent version, and it was pretty amazing. So,
Does he have a day job?
I feel like any company should just like pay him to do all this stuff. He does have a day job. He's a CTO of a company. I forget what it is off the top of my head, but he also runs the San Francisco Angular meetup. He's a really nice guy. But every time he comes up, his most recent thing that he came up with was he figured out how to use machine learning to analyze Webpack builds to like smart lazy load depending on the most frequently used branches or something. He's a genius. I'll never be at that level. but
Angular VR component, is that what that was? Like React has a VR component.
This specifically wasn't. This was just generated, but there are people who are doing VR.
Well, in that bottom right corner, there was the VR symbol.
Oh yeah, you probably can. I guess I've never. Yeah, you're right.
It should do the split, I think.
Yeah, I don't know.
Usually that'll.
Yeah, that is the thing. But yeah, I know that there are people doing that. So let me.
Yeah, because there's a VR component that lets you do all this extra stuff.
And so now we're back to magic, and that was my goal at the end of the day. So thank you for listening, and if you're working on any NG upgrade projects, be sure to check out the demo for my course. And if you need any consulting or group pricing, or just want to grab a beer sometime, shoot me an email. I'm always happy to talk. And if you want to come give a talk at Angular Portland about anything, we're always looking for great speakers for that too. So thanks very much. That's all I got. Yeah.
So is that the slide, where the slide is, or?
Sorry? Oh, I'll post on the meetup the link to the slides for you. Yeah, for sure. And then Angela, do you
Actually, he stole my thunder.
Okay, great. Yeah, I'll post the link. Great. Thanks,
Those are
guys.
cool tools.